Today we're going to discuss a new way to solve systems of equations. So at this time I would like you to copy down the I can statement. It says, I can solve a system of equations using elimination. Elimination is the third and final method that I'm going to teach you to solve systems of equations. This is my personal favorite method. So we'll begin with problem 1. On your paper, copy down the equations for problem 1. The way the elimination method works is we're going to take the two equations and we're going to add them to each other. We're going to add them by lining up the x terms, the y terms, and the constants. And we're going to add straight down the page. So in front of the x we have the invisible coefficient of 1, and 1x plus 1x gives me 2x. The next step is where the elimination occurs. To eliminate means to end or take out or take away. So negative y and positive y, they are opposites of each other. They cancel each other out, so you simply cross them out. Bring down your equals, and then add 1 minus 9, which is negative 8. So by eliminating the y variable, I can now solve for x. Divide by 2 on both sides. Your 2's cancel. Bring down your x equals. Negative 8 divided by positive 2 is negative 4. Now I'm halfway finished. I've found the value of x, but now I need to use this and go back and find the value of y. So since I know that x equals negative 4, I can take that and substitute it into either one of these equations. Since I know the value of x is negative 4, I can substitute the negative 4 for x in either one of these equations and solve for y. So I'll just start out with the first equation, and let's replace x with negative 4. So instead of x, I'm going to write negative 4 minus y equals 1. Now solve for y, so add 4 to both sides. The 4's cancel, bring down the negative and the y. 1 plus 4 is 5. Since that's an invisible negative 1, divide by negative 1, which simply means change your sign from negative y to positive y, and from positive 5 to negative 5. So you have now found the solution. X is negative 4 and y is negative 5. If you chose to graph these two equations, that's the ordered pair where the two lines would cross. In this problem you see we're using p and q instead of x and y. Typically when we use different variables we still go in alphabetical order. So in the alphabet, if we have x before y, then we also have p before q. So we'll just consider p as the x and y as the q in this particular problem. So since I have a positive q and a negative q, these are going to be able to be eliminated. So again, I'm going to add the two equations vertically, keeping my p's lined up, my q's lined up, and my constants lined up. So add 1p plus 1p, I have 2p. Q minus q, the positive and negative cancel out. Bring down your equal, and negative 2 and 8 is the same as 8 take away 2, which is 6. So divide by 2 on both sides, and p equals 3. Once I've determined the value of p, I can substitute this number 3 into either one of these equations. I'll just pick the top one, and we'll solve for q. So instead of p, we'll write 3 plus q equals negative 2. Subtract 3 on both sides. And I get Q equals -2 and -3 give me -5. So the solution since X would be P, then we'll start with the 3. And since Y would be Q, we'll put the -5 as our next coordinate. And these two lines would cross at 3, -5.